Alright, another draft physics video production. Okay, we'll go with that. Comments first, I suppose, and then went on to photon stuff and whatnot, as has been the tradition of late. Yeah, until we get done with this series of videos, and then we'll get back to general subjects and whatnot, and such, and so forth and whatnot. So, FOSology, whatever that is. Okay, your explanation makes sense for permanent magnets. So, I talk about how atoms move to new positions in iron. I draw them. I show how they're in chaos and then they're not in chaos. You know, how you can magnetize iron temporarily. Lots of things could cause the magnet to take magnetization, like putting a current through the wire, or just putting a magnet near the wire, the material, iron, and it becomes magnetic. So, nothing about permanent magnets. Yes, permanent magnets line up this way, but so do magnets that are temporary. So does a nail inside a coil of wire do exactly the same thing I described. So again, you people just can't listen. You can't pay any attention to what I'm saying. You just don't speak English, right? Or something? What? It's just amazing. What about the magnetic effects produced by current carrying wire? You know, that's perfectly acceptable to what I was saying. The atoms are themselves magnetic, and the reason why iron isn't naturally magnetic is just because there's enough heat, enough thermal action to prevent the little magnets from lining up. But if they weren't thermally active, if they weren't being jostled around too much, they like lining up. They like being lined up. That's their preferential condition. If they could be in a very cold place, then I guess iron probably would be magnetic, or close to it. It wouldn't need much. It wouldn't need much aligning. You know, once you aligned it, it would stay. It would be permanent. You know, once you did a lot of things, it would be permanent. So there's, you know, physics is a little bit complicated. Okay, there's always more to stories, but I'm just saying everything in the video I was talking about was the fact that iron has this capacity to become very, very magnetic and then very, very unmagnetic. There was no inconsistency there. Anyway, I just got done with, I mean, paramagnetism is completely different, completely weak source of magnetic effect because it's pretty much superficial, as you know, I'm sort of been pointing out. Maybe I'll do a little bit of that in the end of this video. And I keep looking at the board like, you know, the answer's over there. It was, but it isn't today. So I'm just saying, you know, everything I was pointing out in the video has just, anyway, okay, just calm down. All right. I just got done with a course in electromagnetism, and they took the notion of moving charges of constant velocity produce a magnetic field. Well, of course, yes, I've argued their moving charge notion is idiotic. Charges are charges. Of course, when you move them, you change things. And the whole point is when you move them in certain arrangements, it's magnified. Now, not that magnetism was invented, you know, because it has the word magnify sort of in it or implies it, but it's perfectly understood that way. What you're doing is magnifying effect by having a bunch of things working together, doing the same thing and pointing in a direction, so to speak. But moving charges are, yes, it's their wacky explanation, okay? That somehow when the charge is moving, it's magnetic. No, it's magnetic when it groups together with a bunch of other things and all directs energy in one direction. So it's all this eddy current stuff. Yeah, well, maybe I'll draw it now, some of that. So I could make different, I could come up with lots of ways to describe it, to illustrate it. Yeah, that's enough of a board. You know, why current makes a difference. And I've sort of pointed out that, yeah, well, if you run a current through a wire, what you're doing to the atoms, okay, is you're polarizing them. Okay, you're creating this high pressure that has to go from one side of the atom to the other side of the atom, so to speak, as a transfer. all right, and that they keep moving that pressure. This little line, you could say, moves in this direction, and it does the same thing to the next atom, pressurizes it, and that pressure moves to the next atom, pressurizes it. So it's polarizing atoms as it moves through something. And so if you take that concept of an eddy current, the idea that this current moving is what's polarizing atoms, you could also understand that, say, if you had a paramagnetic material, that is, it had a tendency to create a little eddy current, that would be a kind of a shortcut eddy current, back to the real world. So if I'm running a current through here, I'd end up having atoms, that are creating little eddy currents based on the fact that, say, if I put a magnetic material here, pushing force out, okay, that's causing electrons or protons, to either move in to the material or move out of the material, depending on whether you're an electron or a proton, and that you create pathways that would end up making this electricity go this shortcut and fly out of here as magnetism, because you've basically now made the atoms, you've bent the atoms by putting a field on these atoms, and the atoms are now pointing in a direction, and that you could take advantage of that in the sense the current would now take that path and create an opposing field of the same type because of the way it works in terms of attraction and repulsion. So you end up creating, you're utilizing the fact that the paramagnetism is actually causing the electricity to escape the wire. That accounts for your voltage reduction. Okay, the process ends up using electricity, using it up. Well, how's it using it? Well, it's creating a thermal action, in a sense, in the sense that the energy is being excreted out of the wire as this field, this counter field to the field you're creating with the paramagnetism. Now, this simple arrangement explains why wires move in a certain direction when they're placed in a magnetic field. It explains all that stuff, a simple mechanical process. You don't need a bunch of swirling electrons. And again, what evidence they have for electrons buzzing around protons at 400,000 meters per second, or whatever their notion of its speed is. And how could you sit there and say, oh yeah, well, if I line up, everything's going swirly this way, okay? Somehow I line up all these swirling flying saucers inside of matter, that I'm creating a flow of something. They're like little agitators in washing machines or something, and all creating a bunch of swirly crap, and the swirly crap somehow adds up to a big swirly crap, and there's a bunch of swirly crap around the fucking magnet. Well, what evidence is there for that? What evidence has ever been seen where you place something near a magnet and it does any swirly shit? Oh, that's right, there's no evidence of any swirly shit. So yes, I'm saying their theory is crap. You want to believe it? Go ahead. I can't stop you. I'm saying there's no rational evidence for it. There's no reasonable evidence. You don't need to believe it. It's not essential to understanding anything. But go ahead. I can't stop you. All right? You want to believe they're fables? And they're just fables. They're just stories they made up out of half-truths. They heard something about, oh, there's a Sasquatch living in the woods. And, then they'll sit there and say, yo, I did the experiment. Yeah, I found some fur on some bark. Must have been Sasquatch coming to get me. I mean, they're just stories they're making up on tiny shreds of evidence. And I'm just saying you can take the evidence, the experiments, and you can come up with rational explanations, mechanical explanations. You don't want a mechanical explanation that's reasonable. You want to believe that there's an ether and that the atoms are stirring some sort of ether fields or some sort of crap infrastructure that exists or something, even though there's absolutely no evidence that a magnet's doing any kind of active thing. It's just a filter. It's just reflecting forces or diverting forces, and that's all it can do. It could just create a pathway for bullets, okay? Bullet mirrors, however you want to look. I've given you a million ways to look at it, not a million, okay? At least 6. They're little mirrors. They're little boats. There's lots of ways to imagine why, but there's this force stuff that moves the speed of light, and that stuff gets moved by matter. And it doesn't do any I swirl for no good reason. It doesn't get into orbits. Anyway. as fundamental. They then they use this notion as a foundation for explaining permanent magnets by supposing that there is an associated current to each atom of its material. Yeah, they do lots of stuff. They do an Stern-Gerlach experiment where they shoot atoms into an uneven magnetic field and then tell you that electrons are spinning. They have some spin property. Even though they're not studying what electrons are doing, they're studying what whole atoms do. Okay, the associated current would come from the electron orbiting the atom. Yes, exactly. How does it do that? How does that create a current? How does that create a force? How does that create anything? It's all just stuff with no fucking connections. They have A, B, D, W, Z, Y. That's their alphabet, okay? It's missing a ton of letters. There's a giant gaps in their understanding and in their explanation. Gigantic gaps. Then they make a similar argument as you, namely, no, there's no similar, that in materials like iron, the atoms are aligned in such a way that they combine with each other to produce microscopic effects. Macroscopic effects. Well, again, they're just doing what charges do. I don't know. Is this too complicated? You put a dipole charge, right? A positive on top of a negative, and they have a certain thing. When they're right next to each other, the argument is that they communicate force between each other, okay, kind of directly. That is, the red can go this way, kind of like a diode, right? Where you know the energy can go one way, but it can't go the other way. Yeah, the red stuff can go this way, but the red stuff can't go this way, and the black stuff can go this way, but the red stuff can't go that way. So that's what happens when they're a little magnet. Then you can stack them on top of each other, and that effect will be communicated through them in the sense the same rules will apply. And what you'll end up in the end is anything coming in this way or this way or this way or this way is going to follow those filtering rules. That is, the red stuff can go this way, but the red stuff can't go that way, and the black stuff can go that way, and the red stuff can't go that way. And that's all you need to make a magnet. Period. 2 + 2 + 2 physics. 2 kinds of force, 2 kinds of matter, charge, electron, proton, and 2 kinds of interaction. And that's all you need. And that's all I've been saying. And somehow you're arguing that I've left something out. What did I leave out? What haven't I already explained? Anyway, I know what they think. What they think is what I'm saying is nonsense. It doesn't make any sense to me, so somehow it makes sense to you. Fine. What can I do? What can I say? It makes sense to you. Well, it doesn't make sense to me. Like, I don't know, putting chocolate ice cream on freaking hot dogs. Wouldn't make sense to me. Might make sense to you, but doesn't make any sense to me. Fuck. Anyway. So, it's similar to you. So, again, I don't know why... Why would you emphasize the similarities when the foundations are fundamentally different? They're claiming magical fields do everything, okay? Bent space. Some sort of magical bent space bullshit. Virtual photon. Electric field, magnetic field. I've only argued there's no such thing as any fucking field, okay? You can have soldiers, you can have an army of soldiers, or you can have no army. But there's no field just waiting for you to say, I'm going to move a field. You have to move it with real shit. Real shit has to do the process. Everything has to be made out of something. Not nothing. Not some ambiguous field. There's no field without soldiers. Can't have a field of soldiers without soldiers. Okay. Except you're saying it's from atomic dipoles, not currents in each atom. Well, I've clearly stated that the way you can make atoms line up, or the way you can polarize them, or ionize them even, is to run current through them. So again, where do you get this crap from? I mean, you're just incapable of listening. That's all. What can I say? Where could you quote me? When you say I'm saying, could you quote where I said it? All right. Then this James Edward chimes in. This guy, DraftScience, is an absolute loon. Right. Prove it with what? What argument will you make? So again, this is, if I'm so easy to demonstrate that I'm wrong, well, why don't you do what the physicists do when they argue flat earthers? Why don't you argue some facts? Why don't you argue some experiments? Some real world observations that demonstrate you're right and I'm wrong? Oh, that's right, you can't, because then you'll just say stupid things like, well, the Eddington experiment proved, Einstein proved, when you didn't prove anything. You didn't come close to the burden of proof. Okay. View his video on the theory of everything. Yeah, a video I made, 6 years ago. But yeah, I'm not ashamed of it. Fine. Yeah, it has the basic concepts in it. So, I hadn't called it 2 plus 2 plus 2 physics yet, and I haven't done a lot of things, but yeah, it's fine. But why do that? When you just go to my subject playlist, okay, and see the arguments I'm making on these different subjects, explaining how electricity, magnetism, gravity, and nuclear functions, how they actually work. Alright, it's a rambling mess of incoherent, sprinkled with a little bit of misunderstood, misused jargon. And you proved that with what? You demonstrated that how? Oh, that's right, you didn't do it at all. You didn't quote anything from it. Not a single thing. You can't find one flat earth goofball thing I'm asserting. Venus is made out of cardboard. You can't find one single assertion I'm making that you can sit there and debunk. Not one? Okay, I'm serious. Like what? You're seriously stupid? You're seriously unaccountable? You're seriously an anonymous cowardly troll? Yeah, that's about it. He's delusionally psychotic. And you demonstrate that with what? I mean, the delusionally psychotic are pointing to like Sasquatch things and stuff. So why don't you do that? Why don't you just do what your obligation is to take what I say and prove that I'm wrong? What's so difficult? Walter Lewin, okay, the guy who believes there can be 2 voltages in the same place and who argued that radio waves are both standing waves and moving waves. Used exactly the same experiment to illustrate moving waves and standing waves. Exactly the same experiment. Brian Greene, who is a loop-de-doo, whatever it is, gooey theory, a string, rubber band theory. He's a rubber band theorist. Yeah, and Sean Carroll, who just wrote a book about how he thinks multiverses are the right answer. That's the way to go with the real wacky religion. Go full religion. All right, and others, I'm sure, are all wrong according to him. Well, they're wrong. I've demonstrated. I've played their videos where they say shit that's just preposterously stupid. So what? What else can I do? I mean, again, you really think there could be 2 voltages in the same location in a wire? The wire can both be 50 pounds of pressure and 500 pounds of pressure. You think that's a possibility in the physical universe? Well, then you're a fucking idiot. All right. I'm sure are all wrong according to him, except when they're merely teaching well-established scientific theories. Yes, when they're in the safe zone, what goes up goes down. Yes, okay, once in a while they get it right, but fundamentally they have no clue how any of it elementally works. Professor Lewin says that right in this video, right? I mean, we don't know what a photon is. We don't understand it. That's why we have this duality silly answers, because we don't know what the fuck's going on. All right. If you don't believe me, check out his videos on them. Yes, go ahead, do that. And then view some of his lectures, videos, and podcasts and decide for yourself. Yes, exactly. The only question here is whether his delusion comes naturally or is drug-induced. So again, just no useless crap arguments. I mean, I could say the same thing about Professor Lewin or Sean Carroll or Brian Greene. You think Brian Greene can't be accused of being on coke or something? The guy's a fucking goddamn jumping around, hop, skipping, and jumping all over the fucking place. I mean, he's got James T. Kirk syndrome, so fucking goddamn bad. The amazing I mean, he's fucking spastically insane. Is that what we should pay attention to? That he has, he was way too anal with his mummy? Oh, fuck. Having him dialogue with him and leave you 20 IQ points stupider. So this guy wants to have a competition. You can't make a valid argument against something you're claiming to be as bad as flat Earth, and yet you can't make one single physics argument. All you can do is insult how I look. I mean, fuck you. So lame. If you're finished a course on electromagnetism, you already know far more about reality than this moon bat, whatever a moon bat would be. He believes there's moon bats. Yeah, you're quite delusional, fellow. I'm not making any claims about any bats on the moon, shit for brain. But I am making the claim that people do have shit for brain, in the sense that their neurons might as well be anus neurons because they're not doing anything useful with them. Alright. So, yeah, fuck you. It's not even close to an argument. Shit. I mean, this really isn't too tough, right? Draw a picture of how the interferometer works. Go ahead. Draw me your best diagram. Physics' best diagram of how it works. You know, just show the light moving and where it interferes with itself. And I'll show how it's a pile of crap. And it is. Their understanding is crap. All right, you want to defend it. Why? Because you're religious. You're a devotee. You want to lick the Pope's butt. You know, that's all. You're gay for religion and woo. All right, I'm gonna delete your comment just because it's so badly premised. I mean, I just explained how atoms move, change their position to. You know, I even use some word like you know, where they complement each other. You know, I mean, and you say something as stupid as, well, that's permanent magnets. No, a permanent magnet wouldn't have anything to do with the atoms moving. I wouldn't have to draw atoms moving if I was talking about a permanent magnet. So, you know, false, paraphrase, wrong premise. Bad way to start a fucking comment with, frankly, a grotesque inaccuracy. Okay. So, moving on. Yeah, that's enough. Oh dear, the ads.
YouTube TV.
Yeah, I'm
Try
just
it free.
so excited to see what's on TV. Can't wait.
We're going to go to the other side of the spectrum. We're going to look at radio waves, the very longest waves of the electromagnetic radiation band. So if we go back and take a look at visible light rays, imagine that this is a piece of paper, and let's take a look at the side of the piece of paper. So in other words, let's take a piece of paper and look at it. Just edge on like that. And the width or the thickness of the piece of paper is about 1/10 of a millimeter. Now, as light zooms by, let's say there's a beam of light zooming by this piece of paper, and of course it's doing that at a speed of 186,000 miles per second.
Yeah, the same speed, gravity, and everything else is moving. So again, all the forces. So yes, photons are a force.
While it's passing by this width of this piece of paper, light will go up and down 200 times. The frequency.
So he says light will go up and down. I mean, do you really believe this? Do you people really believe that there's some elemental function in the universe that goes up and down? You really think that's possible, that it somehow knows go up, go down, go up, go down, go up, that it just sits there and says, that's what I do, I'm the go upper and the go downer? I mean, as a metaphor even, you know, let's concede that he has some other notion that no, nothing's really moving, it's just that the field gets fat for no good reason, and then it gets thin, and then the fat, and then it gets thin, and then it gets fat, and then it gets thin. You know, these two different fields are getting perturbated somehow by the magic perturbation device. I mean, it makes no sense. I mean, it's mush. It's how can you see something in this bowl of mush? You're looking into a bowl of grits or something, and you're swirling it around saying, tell me the truth, magic grits. How can you see this? You're seeing this wavy thing? This is what your brain says, yeah, the universe is made out of wavy, thingy, liney, up and downy thingy. Oh, God, it's pathetic.
The vibration of light is so enormous that as it speeds by and spends an incredibly small amount of time passing by the thickness of this piece of paper, it will go up and down 200 times, and that's what I'm trying to illustrate here. There are 200 wavelengths of light as it passes by the thickness of the piece of paper, it only being 0.1.
Right, and your theory is that it's doing that in this kind of a, you know, actually it's a lot of distance. It's 2,000 atoms for every one of those little things. It crosses 2,000 atoms, you know, every time one of those little waves is going by. So somehow you think this thing that's 2,000 atoms big in terms of its how much space it's covering is somehow affecting one little tiny electron. Something a million times smaller than it is. Somehow it's affecting that, and only that. That's kind of lame.
Millimeters thick. Now compared to that, radio waves are enormous in size and length. The wavelength are as much as from 1 millimeter, which of course is 10 times the width of a piece of paper. So one wavelength will then equal to 400 wavelengths of visible light for the very smallest wavelengths of radio waves, all the way to as much as 100,000 meters, which is 100 kilometers.
So the word radio waves doesn't really mean anything, right? There's no line that goes, okay, it's radio waves, it's not radio waves. These are just titles given to general frequencies, to general packets of the force in this different way. And again, this simple explanation for how you can possibly have this huge range of manifestation of what we call the same energy, right? Electromagnetic radiation, is the fact that you can understand that, yeah, I could shoot a gun, 500 times a second, or I could shoot a gun once a second, or I could shoot a gun once a week, or I could shoot a gun once a month. That the gun argument explains why there's different wavelengths. That the only thing that's really important is the fact that there's a quanta going by. How many quantas go by the piece of paper is what you really want to figure out per second. And all of their math, when he does some math here, will assume the exact same amount of time and a full number of bullets. So he'll compare something like a giant radio wavelength, which only has a bullet every second, let's say, right? I mean, at the speed of light, it'll take a whole second before one bullet goes and then another one finally shows up. And then you're talking about like billionths of a second for the light, photons. And what they'll do is take the same time interval and measure those two things in the same amount of time. And that means they'll make the ray length for the light 1 billion bullets worth, right? Or 1 million bullets worth. And they'll make and the radio wave only has 2 bullets, right? So in 1 second, only 2 bullets, right? For the radio wave, and there's like 1 million bullets for the light, because they fill all that in. They take that as a complete 1 second interval and say it's continuous through that whole second. And then come up with these insane numbers to say that somehow the energy of the radio wave is 1 billion times less. When if you got hit by one of those bullets, it would be as real, okay? There's no difference in the bullets. There's just a difference in their fake notion that the ray is any length they want to make it at any time. They can fill in as many extra bullets as they want by just making the time interval longer. When I think if you got any reasonable senses, that these all are confined ray lengths. That all these hunks of energy come in little lengths also. It's only 10 bullets in the gun. You can't make it 1 million bullets through your imagination.
Wow, that's the distance. That's half the distance from LA to San Diego. So that's a huge wavelength. The frequency, proportionally, it's only 3,000 hertz for wavelengths of this length and 300 gigahertz for wavelengths of 1 millimeter. Still, that is a very small frequency relative to the frequency of visible light. So we'd like to talk about light in terms of light behaves like waves, because there's a lot of experiments that we can do that shows that, yes, it has wave-like properties.
Okay, so there's an experiment that shows. It doesn't show in any way except if you bend your eyes, let me look at it like a physicist. Then you can see what you're saying there is. Universe is being created and other kinds of horse shit. All right, but it's only any of that stuff because of the way you're looking at it. And it's so obvious how perverse their vision is, in the sense that they make up all these experiments that they never did with detectors. They tell you what happens when I have my detectors on, even though they never made a detector, never had it turned on, and they certainly never turned off their non-existent detector. But they'll tell you the experiment says so, when no, they never did the experiment. It's just horseshit. And then they'll talk about, well, we send single photon. Well, how do they know they sent a single photon? Do they have a single photon gun? Do they actually have a gun that can fire one little quanta at a time? No, they have no such gun. They have no experimental proof that they ever fired a single photon in their life. Yet they'll claim they did the experiment. No, you really didn't. If if you're really careful and give a shit about the truth, you won't say that you ever knew there was a single photon in the experiment, because you have absolutely no way of making a gun that shoots single photons. There's no theory for even making the gun. And that's the truth. But fuck that.
And light also acts like particles, and there's lots of experiments we can do that show that light does indeed behave like particles. Matter of fact,
so again, even those experiments are sort of bullshit, as I explained, because those experiments are also dependent on a flaw in your theory, in the sense that your receiver can only receive bullets. You can only receive the tipping point argument, right? So you only receive the bullets that knock over the little pegs. And all the other bullets, you don't ever see them. You can only see the pegs fall. You can only see when electricity is created by the photons' interaction. So you have to have it in a clump or a bulk, because that's the only way you can detect it existed, because you have to watch something else happen as an effect. You can't see the cause, and that's a fact. We can't see photons. We can only see electrons affected by photons, and electrons are only affected in a way we can see when they're knocked over, when certain big events, they actually fall over. So you can only see, it's like seeing a kid swinging, and you can't see the kid when he's swinging back and forth, and the only time you see him is when he goes all the way around and comes back. Then you see it. There's a rule, and they know that. They're not stupid. They should be able to figure that part out, that they can't see photons. They can't. They have to see what photons do.
Einstein received the Nobel Prize for doing the photoelectric effect, proving that light acts like...
So he just said proving. And again, it didn't prove it. As much as I want you to understand that it is quanta, it is particles, okay, as much as that's on my side of the argument, it's not a good proof. Just as your wave theory isn't well proven. They keep saying they proved something when they didn't come close to the burden of proof. And all you people think you're being intellectually honest by saying, oh yeah, they did prove it. You really think you can intellectually, reasonably, fairly, in any kind of honorable way argue that this physics has been proven? Shit.
Particles. So when it comes to radio waves, where radio waves are this enormous length in wavelength, can we still talk about electromagnetic radiation of that type as being quantized as photons? So what is a photon?
Yeah, that's when you can do it. That's when it seems even more rational to understand that it must be a bullet. Because that's the only thing that can explain. You can't really explain how you have a wave perturbation that's miles long. That doesn't sound quite right. That sounds even more implausible. But the fact that you'd have a quanta, a clump, that can have a mile distance between the clumps. If you fire the bullets, and they're going 10,000 miles an hour, well, I don't know how much distance that means per second, but it's a lot of distance, okay? So the bullets have a lot of distance between each other.
You think radio waves are quantized like photons. And so the best way to kind of draw an analogy to that is to, first of all, let's see how much energy is contained within a single photon of, let's say, radio radiation. Let's try these two different sizes.
So now we're stuck with the fact that they're so confident that this frequency thing means energy when it doesn't. It means one form. It means one capacity to affect electrons. It's your ability to move an electron out of an atom. Not to move a free electron. No, we're talking about moving an electron out of an atom, and to create an electrical current. So all they're getting is electron volts, which is volts period. And so they're just saying, what makes voltage? Well, yes, frequency makes voltage. You have to have the frequency to tip something over. A slow you have to, again, it's a simple rebound. Do you people really think that this doesn't have anything to do with the fact that the electron is caught in tension? It's stuck in the atom, and it's difficult to move it out. And what photons do by having a higher frequency is move that electron further, because the electron doesn't spring back to its original position. You really don't think that's how it works?
Let's try one at 1 millimeter, and let's try one at 100,000 meters. So again, the energy contained within a photon is Planck's constant times the frequency, which is
just rubbish as a notion of what the real energy is. What's the real effect in terms of creating heat, are disturbances of any kind, any form of energy, including gravity. That's its real energy. The fact that it's full of little quanta, that's the real energy. Little bits moving the speed of light. And yes, the little bits can do special things, whatever you want to call it, when you apply them in volume within a limited time period. That means you can knock things over.
It's equal to Planck's constant times the speed of light divided by the wavelength. And I like that formula better because we usually talk about wavelengths, not so much about frequencies.
And for what good reason? Yeah, none, because they're exactly the same thing. Just an inverse way of measuring exactly the same thing.
And so this would be equal to 6.626 times 10 to the minus 34 joules times seconds, multiplied it times 3 times 10 to the 8 meters per second for the speed of light, and divide the whole thing by the wavelength. Let's start with 1 millimeter here. So that would be 0.001 meter. And so what would be the energy contained within one of those photons?
So let's understand there's absolutely no time component in this equation. That means it's assumed that this is a statement about the same time volume is what you're getting. So the end result is going to be, this is how much energy it would be if you had a photon this long of light, or a photon this long of radio waves, or a photon this long array, this long of whatever they're measuring. And obviously the thing at a higher frequency is going to have more elements in there. So obviously they're contriving a description by leaving out one of the fundamental variables, which is how many times can you fire the gun? How many bullets are in the gun? Is there a limit to how many bullets you can put in the gun? So that's the simple argument I'm making to you. They're basically arguing, no, I can put as many bullets as bullets are imaginary. I don't have to actually shoot real bullets, when nature has to shoot real bullets. So you have to explain if you have a billion bullets heading somewhere, you have to explain where the billion things came from. Those billion elements had to come from somewhere. You have to account for them. You can't just have your mathematical equations say, oh, it always comes that way. No matter how big a package I put it in, no matter how big the box is, the little BBs just imaginarily pop into the box. I don't have to make more BBs. I can make the box bigger, and I don't have to make the stuff inside. I have to add volume. They just magically produce all by themselves. I just make the box bigger, and I'll have more stuff in the box. I mean, it's as bad as their gravity nonsense where they think they can make an infinite amount of gravity. Nature has an infinite amount of pressure. No, it doesn't.
So it would be 6.626 e to the 34 minus times 3 e to the 8 divided by 0.001, and that gives us an energy of 1.98 times 10 to the minus 22 joules. And then if
and then it's going to convert that into electron volts. So this is like me with the Volkswagen argument or something else. I'm just saying, as soon as I make the Volkswagens closer to each other, somehow I can just make new cars. I don't have to get them from somewhere. They automatically just show up for me in my equation. So I'm going to compare a row of, because I'm going to put the cars just 2 feet from each other, right? So in radio waves, I put cars a mile from each other, and there's only 2 cars, right? And now I'm going to compare that, where I'm going to say, well, no, they're a foot apart, but still make a mile worth of cars. Because I want to make an even comparison. 1 mile of radio waves and 1 mile of Volkswagens at a higher frequency. And they're just making the cars. This is just bullshit to say it actually has that energy. It doesn't have it.
we divide that by 1.6 e to the 19 minus, we have an electron volts. So that would be equal to 0, oh no, not 0. Where's my eraser? Oh, I have my eraser with me. All right. So that would be equal to 1.24 times 10 to the minus 3 electron volts. So a little bit more than 1/1000 electron volt. That's not a lot of energy contained within one photon of that kind of radiation. Now what?
But it's going to be a huge amount of energy compared to the thing that's 500 meters long.
What happens if we go to this wavelength? So this would be for 1 millimeter wavelength. So now E equals HF equals hc over lambda, for lambda being equal to 100,000 meters. And so that would be equal to 6.626 times 10 to the minus 34 joules times seconds. times the speed of light. And now we divide it by the wavelength of 100,000 meters. So 100,000 meters compared to...
So it's all just constants divided by a wavelength to get your result. And again, it assumes the rays can just fill in all the missing bullets. So you could just make bullets for free.
That's an enormous difference. So 6.626 e to the 34 minus times 3 e to the 8 divided by 100,000 equals, so that's an energy, so that's an energy equal to 1.98 times 10 to the minus 30 joules, and converting that to electron volts.
So the other number was 28 or something, or 20 something, and so 30, yes, it's less. And once you start doing this multiples of tens into the double digits, it's kind of preposterous in terms of a number we can understand. I mean, you're talking about a billion.
That would be 1.24 times 10 to the minus 11 electron volts. So you can see that we can think of radio radiation, radio wavelengths, as being photons, but then if we do, the energy contained within a single photon is so very small that measuring the effect of that would be virtually impossible. So it may be thought of as photons, but in all effectiveness,
so that is just such a bogus argument, right? So what he's really saying is, well, yeah, they're really small things, and the numbers are really big, so we can't do it. Yeah, that's right. But it's not. Doesn't mean that there isn't explicitness in the reality that all of those little things count. All of that energy does count. It all does move something. So bogus.
It's hard to see how a single photon can do any kind of reaction with a single electron or single anything because it carries so little energy. So if a photon that large is incident on a single electron, the effect of that would be so minute you probably wouldn't be able to measure.
So that's the bogus part. It's obviously I could make a bazillion of them and they still won't affect electrons the same way because they lack the frequency to do so. Again, it's a tipping point argument. Yes, you could hit the thing forever with a huge volume. So even though it's a tiny amount of energy, well, let's just say I can make an endless number of it. I give you a zillion bullets at that frequency. Yeah, a zillion volts still won't cause it to tip. Just like I can't make a pendulum swing by hitting it when it's coming towards me. I can't hit it when it's coming towards me and get the pendulum to swing more. That's just a fact. It has nothing to do with saying it doesn't have energy. Just so bogus.
A way to think about it would be, for example, to think of the other side of the coin, because we know that particles kind of behave like waves, especially when they're very small.
Yeah, so that part makes sense. That's right. Okay, it's an emergent. Wave is an emergent property. Waves aren't an elemental property. Nothing is elementally waving. There's no frickin' at the elemental core of the universe. There aren't some kind of jellyfish going blah, 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 blah. That's not how the universe works.
Small particles are like electrons, and you can actually calculate that wave, the wavelength of those small particles, like this was invented or at least discovered by de Broglie.
Yeah, it wasn't discovered. It's part of just a written dogma into the book of dogma. He wrote in a pile of crap that frequency equals momentum. And it's crap. It's not the truth.
And so therefore, if we then calculate, let's say that the particles move at a speed, velocity equal to 10,000 meters per second. So let's go ahead and calculate the wavelength of an electron moving at that speed, a proton moving at that speed, and eventually a basketball. Now for a basketball...
Right, so now he's going to give frequencies to things that don't have a frequency. So I just throw a baseball, and he's going to give it a frequency. He's going to tell me its momentum is its frequency. Does that make any sense? No. How can people say this has any kind of... this is a coherent theory when they're doing something so obviously wrong in stating that we're going to use frequency as a replacement for momentum. Momentum already has a definition. It didn't need to be redefined. And this is a stupid redefinition. Frequency is not momentum. It only is momentum in the circumstance of, do you want to create an electric current? If you want to create an electric current, you're going to need a specific frequency.
We'll adjust the speed because it'd be difficult to get a basketball to move at 10,000 meters per second. So anyway, the wavelength of an electron moving that fast would be Planck's constant divided by the mass, and then multiplied times its speed, which let's say 10,000 meters per second. And that would be the wavelength of an electron. So we have 6.626.
So again, in a wavelength, how? How is that the wavelength of an electron? So you're making an electron move, number one, at a speed it doesn't move at, but whatever. And you're saying that I'm just going to sit there and compare this, number one, its fake notion of its mass, and convert it into frequency instead. So we'll just ignore its mass, we'll just pay attention to its velocity, and give it an arbitrary number of magnitude points. We'll just say this is how much of a bullet it is, when they haven't really accepted the fact that, no, its substance is made of something. The substance of the electron is something, okay? And you can measure its momentum in the sense you can measure its mass by hitting it with something and see how fast it goes.
6 e to the 34 minus divided by 9.11 e to the 31 minus and divided by 10,000 meters per second. And that gives us a wavelength of about 73 nanometers. So that would...
So they gave it this R, a fake velocity, and then just say, well, that equals a frequency. It doesn't. There's no description of it moving in some frequency. It's moving in a straight line in a direction. Where's its frequency? It doesn't have any frequency.
It would be kind of like the wavelength of ultraviolet radiation. If we do the same calculation for a proton moving at that speed, let's find out what the wavelength would be. So for proton, the wavelength would be...
So it's going to be pretty obvious that it's just going to be a multiple of its mass, in the sense that they're just going to play the same game and say mass is volume, which it isn't, size, and play this game that somehow it has a frequency. And it's obviously going to be some number much lower than that number, 1,000 times lower, 1,200 times lower.
H over mv, which would be the same Planck's constant, 6.626 times 10 to the minus 34 joules times seconds, divided by the mass of a proton is 1.67 times 10 to the minus 27 kilograms. And let's say that it's also moving at about 10,000 meters per second. And that would give us a wavelength of...
So, like you said, you don't even have to do this math to figure it out. You just do it. You just multiply it by how much bigger you say the electron is, and then you got the frequency. So they're just turning mass into frequency.
Divided by 1.67 e to the 27 minus, and divided by 10,000 equals, and there we would get a wavelength of about 40 picometers, which is 40 times 10 to the minus 12 meters. So it would be less than a 1/1000, about 1/2.
Oh, okay. So they're making the frequency, as your frequency goes up as your mass goes down. So that's, as your mass goes up. So the bigger you are, the smaller your frequency. So they have this inverse relationship. So because higher frequency means more momentum to them, because they've turned frequency into momentum. So just understand. So, but yes, it's 1,000 times, 1,200 times bigger than the electron. That's all. So it's a picometer because it's 1,000 times smaller wavelength. He's doing wavelength, not frequency.
1,000, the wavelength of an electron. Now that would be a very difficult wavelength to measure. And now let's go to a basketball. Assuming the basketball has a mass of about 0.5 kilogram, and let's say that the velocity of the basketball is 10 meters per second. We throw it across the basketball court, and again, if we're correct, particles also behave like waves. So what would be the wavelength of a basketball moving at 10 meters per second? Using the same equation, we can say that the wavelength is equal to h over mv.
Just jump ahead
V,
because this
that would be
is too stupid.
6.626 times 10 to the minus 34 joules times seconds, divided by the mass, 0.5 kilograms. That would be a 5 right.
We know that what makes all these things different is the fact that they have a different mass. Yes, heavy things moving the same speed as light things will have more force in them, and they'll release more force. Duh.
Here, kilograms, multiply it times the speed of 10 meters per second, 10 meters per second. So what would be the wavelength of a basketball? Imagine throwing a basketball across the court and seeing it move like this instead of like in a straight line or a parabolic line. So let's find out. 6.626 e to the 34 minus.
Right, so I'm supposed to imagine something totally ludicrous, that the basketball's forward motion is defined by how much it's doing this, that its momentum is a function of its vibration, or its whatever this is, its unstraightness, the speed at which it's unstraighting. It's absolutely contrived nonsense. There's absolutely no reason to convert frequency into energy. are momentum. You already have the way you decide momentum. Momentum is moving mass at a speed. That's momentum. It has nothing to do with frequency. And it only has something to do with frequency when you want to make electricity.
Divided by 0.5 divided by 10 equals, and so that has a wavelength of 1.33 times 10 to the minus 34 meters. Now, that's a wavelength we're never going to be able to measure. That wavelength is so small that for all intents and purposes, even though we said that all particles have wave-like properties, when they get to be as big as a basketball, finding out the wave-like property is impossible to do. It's just
Again, it wouldn't matter, but you can't see, you shouldn't even be implying that, right? Because if you measure the energy that comes from a galaxy billions of light years away, okay, based on how much hits you, all right, it's infinitesimally small. But the fact is that the actual photon hitting your eye is just the same as the photon that left billions of years ago. If I was 1 foot or whatever, within some range of, within a small distance of the galaxy, or I'm far away, when the energy actually does its job, it's exactly the same amount of energy. So that's what makes the universe run, is a bunch of stuff doing stuff, really weak stuff, little tiny bits of photon hitting something. It hits an electron and it moves it real distance. It tips it over. Okay, a photon that traveled billions of light years across space is tipping over electrons here. The tip is real. It's not meaningless or infinitesimally small or any of that horse shit. When it actually hits something, when the bullet lands, it's still a fucking bullet.
just not going to happen. So even though we know theoretically basketball should behave like waves,
I mean, if somebody shot a bullet, say 1,000,000 years ago, right, and the bullet just kept going around the Earth, and it finally its orbit degraded, and it comes down and it hits somebody, they're just as dead.
to a very small extent, only when we have very small particles like electrons can we actually see the effect of the wave-like properties. And for a proton,
So there's no seeing the effect of the wave-like properties. There's no wave-like property. It's all contrived. Okay, electrons aren't waving, protons aren't waving. All this stuff doesn't have a frequency. It's just contrived nonsense. They had a perfectly valid way to understand momentum, and they converted it into their wave theory. They forced it to be a wave by saying frequency is now how we define momentum. That's all they did. There's nothing in the facts or the experiments that require them to do that. It's just their way of waving physics, waving goodbye to the right answer.
as well, but not as good as for an electron. So going back to electromagnetic radiation and photons, when we talk about the very small photons, the photons of gamma rays and X-rays and UV radiation, and yes, even visible light, they definitely behave like quantized pieces of energy called photons. And Einstein did a tremendous experiment proving that that was the case.
So again, he gives in, that's the proven. No, the case that proves it are the things with the giant wavelengths. They're the ones that make you say it has to be a quantum moving at a period in time. It has to be a clump, because nothing is stretched all of that distance. A mile-long photon? Come on. Quanta that's a mile long and has a jello shape for a mile. That's the part that sounds ludicrous.
But when we talk about radio radiation, when the waves get to be as long as 100 kilometers, can we think of it still as individual quantized pieces of energy? So
Yes, but that's how it's coming off the antenna. There's a bunch of little pieces. Yes, all bunch of soldiers all lined up. They all leave at the same interval. So there's a whole bunch of soldiers. And if you just sent one little ray of them, yeah, they couldn't do shit. Okay, but yeah, a whole bunch of them can do something. That's why you have to pump the antenna full of megawatts. That's why radio stations say broadcasting at 1,000,000 megawatts. You know, it's because they're pumping a ton of fucking goddamn energy into the antenna. Shit.
that if a photon is incident in something, it can, in an instantaneous moment, give all that energy of that photon into some other property. The answer is yes, in a way, but not really where it can be noticed. Because
Yes, it's yes all the way, and it can be understood that waves are emergent properties. Waves, soldiers don't wave. That's not what they do. Soldiers march, 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 march. Okay, they don't wave anywhere, but a whole bunch of soldiers can wave somewhere. That's the simple logical answer.
Because the energies that we're talking about, especially when the wavelength gets to be 100 kilometers, 100,000 meters, the energy within one photon is so small, 10 to the minus 11 electron volts, that we really can't measure the effect of.
Yeah, unless the bullet hits you. If the bullet hits you, you're not going to be talking about how, oh, that was nothing, that was so small, I didn't even feel it. No, that's not going to be your experience.
That. So it's almost like trying to measure the wavelength of a basketball.
I mean, if I made a galaxy that actually shoots bullets, right, real bullets, and I put it a billion light years away, you'd still be kind of afraid of it, wouldn't you? Well, what if one of those bullets hits me? Right? Because they're real bullets.
It's trying to measure the quantized energy of a photon of very long wavelength radio waves. So theoretically, yes, they are photons, but in practicality, it's not going to be able to be measured. And so that's where you begin to blur the concept between radio radiation being more like wave.
So again, no, it's more like a lot of soldiers, and you can just visualize them coming off the antenna at lines of soldiers, line of soldiers, lines of soldiers, lines of billion soldiers, billion soldiers in lines coming off the antenna. Makes perfect sense.
It's like particles, where gamma photons are much more like particles than they are like waves. And that's why there's so much confusion about the concept of photons when we're talking about radio waves.
No, there's so much confusion. There's so much confusion because you have very, very little evidence, and you've built a whole big silly story on top of this stuff that is just fabulology. Okay, it's speculophysics. You haven't done your job. Okay, to prove any of the stuff you're saying. We found it, we've got it, we done it. Just like LIGO, you didn't do it necessarily. You haven't proven you did anything. You're just saying you did something.
Again, it's another window in our understanding of.
So the window is duality. Oh, it's particle-y, but it's wavy. It's particle-y, wavy, particle, wavy, wavy, particle. I don't know. Blah, 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 blah. When logically you can understand that yes, particles can do wave really easy. Wave doesn't do particle.
What photons really are.
All right, so another whatever adventure in whatever this is I'm doing. Yeah, and so till the next time I attempt to do some more of it. I shudder at the thought, because it's just, this is worse than being a quadruple retard teacher. You don't just have the normal retards, you got the real poo eaters. Ugh. It's a really dirty job, but I suppose somebody has to do it. Ugh, communicating. I kind of wish there was a galaxy that shot bullets.